Good day. I'm a first teacher and I'm going to explain all about the prism. So, before we proceed in defining the prism, let's first define what is a closed prismatic surface. A closed prismatic surface is when given a moving line and convex polygon, so that this moving line touch the boundary of the polygon and made to traverse it completely. So you can see that there's a line here and it is parallel to itself. So this line and this convex polygon made up a closed prismatic surface. And this moving line is a generator of the surface, or also called as the element of the surface. So now we can define the prism. The prism is a polyhedron. It is a polyhedron because it consists of plane polygons, and you can see there are many polygons here. So that which bound by the prismatic surface and two parallel plane section, which is these plane sections cutting all the elements. This and this cuts the elements. The next lesson is to identify the base, the lateral surface, and the edge of this prism. So the base here is the two parallel cross section, which is this and this. These are the bases. And the lateral surface are the other faces, which is this. And this is a lateral face. So the edge here is this because two plates meet in this line. So this is the edge. The last lesson that I will teach you is all about the right section and the right prism. So when you're talking about the right section of a prism, it's when it gets all the edges at right angles. So you can see that the right section here is this because this base cuts the edge into right angles. So you can see, and a right prism is when the basis of this prism is a right section, then it is called a right prism, and this prism is a right prism.
Good day, class. I'm here to discuss corollary 1, 2, 3, and also kind of prism. Corollary 1, the lateral faces of a prism are parallelogram. These faces and these faces are parallel, and the base of this, base 1 and base 2 are parallel. And corollary 2, the lateral edge of a prism are equal and parallel. These edges are equal, and these edges and these are parallel. Corollary 3, the lateral faces of a right prism are rectangle. These faces kind of prism. There are many kind of prism. Triangular prism, rectangular prism, and hexagonal prism, and pentagonal prism. And I have here rectangular prism. If you say rectangular prism, the base are rectangle.
Good day, class. I am your last teacher for today, and I will discuss about altitude, area, truncated prism, and the last parallelepiped. First is altitude. Altitude is a perpendicular distance between the planes of its bases. Here, I have here the example of rectangular prism, and this is our base 1 and base 2. And the between of these two bases is the altitude. Whatever the measurement of this altitude is equal to the distance of the bases. Lateral area. The lateral area is the sum of all faces in our prism, and the total area is the sum of all faces and its bases in our prism. I have here a triangular prism. We all know that the triangular prism has three faces: the face 1, face 2, and face 3. So we can conclude that our formula is the lateral area is equal to the area of face 1 plus the area of face 2 plus the area of face 3, or simply as the lateral area is equal to the number of faces times the area of face. Then the total area, the formula of total area is the total area is equal to the lateral area plus, since our base here is 2, so 2 times the area of our bases. Then example, I have here the triangular prism. If our width of our triangular prism is 2 and the length of our triangular prism is 4, we can conclude and we can know that the area of our face is 8. So since we have the area, we can apply this to find the area of lateral area of this prism. So if our face 1 has the area of 8, so we can substitute this to 8. Then the area of face 2 is also 8, and also the lateral area of face 3 is 8. So we can add these 3 area of our faces. So 8 plus 8 plus 8 is 16 plus 8 is 24. So the lateral area of our triangular prism is 24. Then if the basis of our area is 2, we can substitute this to this formula. So the total area is equal to the lateral area is 24 plus the area is, since the area of our base is 2, so 2 times 2, then the total area is 24 plus 2 times 2 is 4, so 4 plus 24 is 28. Therefore, the total area of this triangular prism is 28. Okay. In truncated prism, I have here a triangular prism. If I cut here into 2, then we can create a 2 prism. Then in this prism, if the base of our original prism, then the new base of our prism is not parallel. Therefore, we can conclude that this prism is truncated prism. Okay class, our next topic is about parallelepiped, and parallelepiped is a prism whose bases are lateral faces and are parallelograms. I have here the example of cubic parallelepiped. The cubic parallelepiped has the same faces. Example, our base 1 is square, right? Then our base 2 is also square, and also the faces are square and they are all equal. And we conclude that this object is a cubic parallelepiped. And also I have also a rectangular parallelepiped. As what you see, our base while our base 2 here is also a rectangle, and as what you notice also, their faces here is rectangle.